Okay, so we had discussed prior to this what happens if you have an inductor, or rather, what happens if you have a resistor and an AC. What about inductors and capacitors? So starting with an inductor, so the inductor, omega, have frequency right here, so V equals V naught sine omega t. Okay, and so we know that for the inductor, then the voltage on the inductor is going to equal L di dt. Okay, actually minus that. Okay, and so di dt, so we're dropping, so the voltage, the V here is going to, be negative of the voltage on the inductor. So di dt, okay, is going to be equal to V over L. So that's going to be equal to V naught sine omega t over L. And so if we want to find I, then I would be the integral of V naught over L sine omega t dt. So this would be equal to V naught over L integral sine omega t dt. So this is going to be equal to minus V naught over L cosine omega t. Now, with an omega out front. Okay, so now you remember that when we had a resistor, that the current in the resistor is going to be V over R. Well, this is not quite R right here. So instead, we define something called reactance. XL equals omega L. So then we can say that the I naught is going to be the V over XL. And so that means that the I equals minus I naught cosine omega t. Well, we said that V equals V naught sine omega t. And so what that means is that the current is not in phase. It's actually out of phase slightly. The negative cosine is following. So what happens is that if we were to graph if that's the voltage, then what happens is the current, so the current lags behind the voltage by pi over 2. And so we would say that the current is lagging voltage. Okay. Next, we can talk about what would happen with a capacitor. So now we have a capacitor. And so again, we know that V is V naught sine omega t. Well, we know that the voltage is going to be Q over C. Well, we know that Q is going to be C times V. Okay, dq dt, that's I. So that would be equal to the derivative of CV. So I is going to be the derivative of CV naught sine omega t. Okay, what does that give us? That gives us that I is going to be equal to omega C V naught cosine omega t. Well, once again, if we look at how we did this before, where I is I naught, some sort of function, then that for a resistor was, for resistor, I for resistor is V over R, so we would want this to be some I naught cosine omega t, where this is going to be v naught over xc, cosine omega t. Well, in order to get that to be xc has to be 1 over omega c. And so the reactance here is going to be 1 over omega c. And again, omega equals 2 pi f. So now if we plot that, then we've got the sine, that's going to be v naught, but now it's a cosine that is, the cosine is going to be I. So now it's leading. And so now the current is leading the resistance, or leading the. So in lab, we said you can remember this by talking about Eli the Iceman. Okay. So for an inductor, the voltage leads the current. For a capacitor, then the current leads the voltage. And so this is how we're going to look at this. And so they are out of phase with one another. And so this is our elements here for inductors and capacitors. So the next step would be what happens if you put everything together and then get a circuit. And so that would be our very next step right here.